What if I asked you, of course, I'm continuing to build my Lego city, and what if I took all my people here and I said, hey, can you estimate how many Lego people I have in my hands? Wow, we're gonna work on estimating today. So grab your math books, grab all of your supplies, and let's jump in. Today I kept one of my friends here because I'm going to need a partner. So you may want to find a partner as we get started. And this game is called Multiplication War. And it looks like she's ready to go and I'm ready to go. So my partner is going to have half the deck and I'm going to have the other half. There's a couple of different variations of how you can play this, but this is a wonderful just refresher of your multiplication facts. It'll help to really solidify them for you. So we could either both turn over a card at the same time, and the first one that yells the product, so when I say that word product, are you adding, subtracting, multiplying, or dividing? Yes, you're multiplying. Okay, so the first one that multiplies these two cards together and gets the correct product gets to keep the cards, and I think I heard her say 49. So she gets to keep those cards. Kind of like war, but we're using our multiplication skills as we go along. Now, another way you could do it is each of you can turn over two cards at the same time, and whoever says their own quicker gets all the cards. 12. Oh, I think I was faster than her, so I got my 12. And then I also have to say what the product is for hers also. And it looks like 8 times 5 is 40. But if I don't say it, if I don't get it correct, it goes back in the pile. Now, what if I yell out a product of two cards, but it's actually the wrong one? Then my opponent, or the other person, gets to actually guess next. And if they get it correct, they get the cards. So have some fun working with your multiplication facts, and I'll meet you right back here. Alrighty, so you see I have my place value chart out again. I don't have my billions out yet, and I'm not sure if we're going to really need our billions today. But let's start with a number. What if I gave you this number? 2,700,000. Okay. And then I asked you to add 7. Let's not do 7. Let's do 6. What if I asked you to add 600,000? Okay. So we're going to add 600,000. There we go. Let's do our addition now. Of course, 0 plus 0. If I don't have anything and I don't add anything, I have nothing. So let's keep going with our zeros and our zeros, and oop! So now 7 and 6 gives me 13. Uh-oh, I can't fit my 13 here, and you've learned this early on in your earlier lessons. I'm going to keep 3 of them here, and I'm going to trade 1 out for millions. So I need to add another millions there, right? You guys have practiced this so much with your place value discs. So if I add these two together, I'm going to get 3,300,000. Okay, so that was pretty easy to do. Now, what if we're working with kind of more complex digits and numbers? How can estimation maybe be helpful for us? Let's start with this number. $7,812,380. And then we wanted to subtract, let's subtract 700 and 1,522. Okay. Now this might feel more complicated to subtract, but if we estimated, okay, by rounding our numbers, which you learned in your last lesson, this might make it easier for us to find our answer, at least to check whether our answer is reasonable or not. So I'm looking at this top number right here. How might you want to round this one? Okay, so I heard from some of you that you wanted to round your millions. So you can look next door at your 8, your 100,000s. It's more than 5. So you want to round this to 8? All right, let's round that to 8. And when we round all these numbers, remember, we take away all the place value discs and they become zeros. Great. Now what about this second number? How might you want to round this one? I heard some of you say to the 100,000s. Great. Look next door, we have a 0. Don't let that confuse you. 0 just means it's less than 5, right? So we're going to keep that 7 as is. And we're going to add our zeros. Now, this feels much easier. Let's begin with our 1s, our 10s, our 100s, 1000s, 10,000s. Uh-oh, looks like we have to borrow. I can't take 7 away from nothing, so I'm going to need to borrow one of our millions over here. So we're going to take that as for a 7, and we're going to add it over here. That's going to give me 10. 10, take away 7 is going to give me my 3, 7, and I'm not taking anything away from my 7 there. It's going to give me 7. So, this confused me because I made that a 7. But what we're really doing is we're still subtracting our 700,000 from our 8 million. Okay? And then as a result, we got 7,300,000. All right? So when we estimate and round, we can kind of get an answer a little bit easier. All right. Okay, so we are going to work now with a little bit of multiplication. What if I gave you 700,000 Legos, right? But not just 700,000, 4 times 700,000. That would be a lot of Legos. If we were going to use our place value discs, in fact, I bet you can visualize this. If I want 4 times this amount, 4 times, I want 4 700,000s. This might help us visualize it a little bit. I already had 7 of them. 2, 3, 4, 5, 6, 7. I already have 7. But if I want 4 times the amount, what might we do? Yeah, I can multiply my 7 by 4. So if I do 7 times 4, what would the product be? Great, 28. So, which tells me I would now have 2,800,000s. Can we keep 2,800,000s in the 100,000 spot? No, we're just going to leave our 8 and move our 20 over to make it 2 million. Okay, so if I took my 700,000 and I multiplied it by 4, we usually will see it over there, right? But it's just telling me that I want 4 700,000s. So I want 4 of these, 4 groups of these, right? 4 groups of, which will give me 28. So really, when you're estimating, working with numbers that have lots of zeros in it, is really going to be a lot easier. Now, if you got an answer of 560, could that be correct? No, you would probably look at that and go, well, that can't be reasonable, because if I already have 700,000 Legos and I want 4 groups of these 700,000s, there's no way I can get 560. Okay, so that's kind of helpful for you to know, a little trick. Looking at your answer, yeah, 2,800,000, that would be reasonable. It would be about that many Legos. Let's try another one. All right, now we're going to divide. So if I gave you this number right here, 350,000. Okay. And we want to divide this number by 5. See if I can squeeze it in here right here. We want to divide this by 5. So we want to take this number and we want to divide it into 5 groups, and we want to find out how much is in each group, right? So if I take here's my 300,000 right there, and my 5 10,000s right here. Okay, now can I divide these evenly into 5 different groups? Maybe a little bit tricky. I could do it with my 10,000s, right? I could have 1 group, 2 groups, 3 groups, 4 groups, 5 groups. But I have a problem over here. What might I need to do? I might need to exchange one of my 100,000s out. But that still might leave me in a pickle because I'd have 2 left. So what if I traded all 3 of them out? If I took all 3 of them and added 30 over here. So if you can imagine, I had 35 10,000 place value discs. I don't have 35 here, but you might at home. So if you can get 35 of them, can they go evenly into 5 different groups? Okay. I have 5. You might already know. You can see that if I take 35 and I divide it into 5 groups, what might I get? Excellent. I bet you said 7. We would have 7 in each group. So if I was to draw them, 1, 2, there's 1, 2 groups, 3, 4, and 5. So we have 7 in each group. Now if I counted every single one of them, how many would there be? 35, right? So if I divide my 35 into my 5 different groups, I have 35 10,000s. That would leave me with, great, 7 10,000s, or 70,000s in each group, right? I have 70,000s in each one. So my answer would be 70,000. Okay, can you see that? Great. And I know many of you can just look at the 35, divide it by 5, know that's 7, and did you notice? 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Okay? All right, let's play with another one. I'm going to give you a little bit more tricky number, and we're going to estimate it to find an answer. So let's see, let's start with this one. 295,812. Okay. And what if we want to multiply this number by 6? Wow. Okay. So that might look a little bit overwhelming. I know you can do it, but let's see if we can just round this number so we can find kind of an estimate of what the answer might be. Now, how do you want to round this number? Okay, we can do that. Let's round to the 100,000s place. Looking at my 100,000s, I'm going to look next door. It is greater than 5, so I'm going to round up to 3. Okay, so this is my new number, right, as I rounded it. Now, as I have this number and multiply it by 6, you think you can do that? Yeah, much easier. You might even can visually imagine that we had 300,000 place value discs right here, but I want 6 times that amount. What might 3 times 6 be? 18. Great. How many zeros might we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Do you see that? Would you agree that 295,812 multiplied by 6 is approximately 1,800,000? Yeah, it's our estimate, right? So by rounding our number, we can find an estimate. And again, if you got a number like 200,000 billion 400 million. You may look at that and go, you know what? I don't think that's a reasonable answer. That can't be right. Okay, now we're going to work on the division again. And we're going to take this number and we're going to divide it by 8. Yikes. Okay, where might we start with this one? Multiplying sometimes feels a little bit easier, but now we're dividing. Here's a little trick. Can you count by 8s? I heard you. 8, 16, 24, 32, 40. We're going to keep going. 48. Keep going. 56. Keep going. One last one. 64. All right, we're going to stop there with our multiples of, multiples of 8. But how might this help us in knowing how to round this number? Think about it for a second. How might knowing our multiples help us figure out how we can round this number? So you might have noticed our first number is a 5 and then we have a 4. Can we find a multiple over here that might be really close to our 5 and our 4, or 54 here? Great. You probably noticed a 56 over here. So we're going to round this number to 560,000. Okay. Now that makes it easier to divide, doesn't it? So if I take 560,000 and divide it by 8, what might 56 divided by 8 be? Good, 7. You're absolutely right. So with my 7, I can plug my 7 in over here. And how many zeros would I have? 1, 2, 3, 4. So if I take 56 10,000s and divide it into 8 groups, I would get 7 in each one. And this would be my answer. Okay, let's try one more. This one's a tricky one. How about if I gave you this problem? Let's take 443,512 and let's divide it by 9. Again, what would we do first? You're ahead of me. Yes, let's find some of our multiples of 9. 9, 18, 27, 36. Should we keep going? Yes, I agree. 45. You told me to stop. 45. That is so close to our 44 up here. So I'm going to round our number here to 450,000. Okay, and I'm going to divide this one by 9. And when I do that, what is 45 divided by 9? Excellent, 5. And I'm going to have 50,000 now. All right, so this would be my estimate, right? So 443,512 divided by 9 is approximately, right? Remember this fun little symbol we use is approximately 50,000. Great, good job, you guys. We're doing so much work today. All right, you guys, very last one. Let's play with one last multiplication one. How about if I gave you this number right here? And we're going to multiply it by 7. So tell whoever is there working with math with you, what would be an estimate of this answer? And how would you figure it out? All right, you guys, have fun, and we will see you next time. Bye.